The VTESS equipment characteristics and capabilities are as follows. The common power supply, CPS, comes in a lightweight, durable, injection-molded case with carrying handle and provides regulated 12 volts direct current VDC, 120-watt power to the VMC for distribution to the rest of the VTESS system. Typically, the CPS is configured to run on one battery but can be augmented by a second battery if operational needs require it. The CPS also can draw power from an external platform source. When external platform power sources are used, the batteries serve as a backup and automatically kick in if need be, preventing problems with VTESS operational capabilities. When using vehicle power, the sensing circuitry prevents the vehicle's batteries from being drained. The CPS detects changes in voltage, causing the charger to cut off when it is not in the correct range. The CPS assembly includes the VMC power cable, CPS input power cable, system bus cable, VIC-3 cable, VIC-5 cable, legacy cable, and 5 additional power adapter cables. The CPS comes with a hook and loop fastener patch for mounting to the back of the vehicle and a hook and loop fastener patch for the VMC. A lanyard is the secondary way of attaching the unit to the vehicle. The Vehicle Master Controller, VMC, is the main system controller which distributes power to the rest of the system and stores all of the system configuration data. It is wired to the CPS and provides wireless communications to the wireless devices that run the Personal Area Network, PAN, and is the main coordinator for performing the built-in test, BIT. The VMC has 7 USB connectors. The 7 cable ports are color-coded and recessed with breakaway connections to minimize possible damage. The VMC is powered by the CPS. The VMC housing assembly mounts to the CPS with a hook and loop fastener patch. The Crew Interface Module, CIM, is the primary interface for the crew operating the VTESS, providing operational status. The touch screen also displays casualty kill information and can display the last 100 recorded events for each VTESS component. The CIM is comprised of the following: the touch screen, the system bus harness, audio speaker to emit voice messages, infrared IR and LPAN window, which transmits IR and LPAN data outside of the unit, audio outputs to the VIC-3 and VIC-5 vehicle intercom systems where available, an internal lithium-ion battery. The CIM attaches to the inside of the vehicle with a hook and loop fastener patch or by a magnet. The Crew Kill Module, CKM, transmits Miles laser codes to relay hit events from the target system to the crew members wearing Miles instrumented vests. An IR receiver on the top is used to configure the CKM to the system through the laser personal network using the CIM. On the back of the unit is the battery cover, a hook and loop fastener patch, and the visual indicator behind the battery cover, which reports battery and bit status. CKMs are strategically placed to cover the entire crew inside the vehicle using hook and loop fastener patches. The Vehicle Kill Indicator, VKI, provides visual engagement indications of the system casualty status for observers outside the vehicle, viewable from 1,800 meters. The VKI also provides wireless communications to the main wireless LPAN hub, which contains the system's GPS and radio antenna. Each target event is reported to the crew as a voice cue on the intercom. The VKI consists of the dome, mounting base, 2 extension poles, 6.5 inches and 19.5 inches, 2 pole couplers, lanyard, system bus cable. The VKI is also wired to the VMC and provides wireless communications to the wireless devices that run the Live Personal Area Network, LPAN, and is the main coordinator for performing the built-in test, BIT. The hook and loop fastener patch on the bottom of the base is the primary means for mounting the device on top of the vehicle. A lanyard is also used to attach the VKI to the vehicle. The laser detector, LD, is a wireless, battery-powered optical detector which reports decoded laser pulses from attacking forces. The optical detector is located in a window on the front of the LD. There are 8 laser detectors, LDs, in the VTESS kit, with combat vehicle kits providing additional optional LDs. The LD associates to the CIM via LPAN IR during installation and communicates via LPAN RF to the VMC. The following are also on the front of the LD. Status LEDs, the push button that initiates a bit test, the Infrared Data Association IRDA interface, the UCAT laser detector primarily used to communicate a simulated weapon engagement from a weapon simulator platform to a target simulator platform. The right window is an LED indicator used to identify the location of the LD on the vehicle, a lanyard and attachment point. The following are on the back of the LD. The hook and loop fastener patch attachment, which is the primary means of mounting the LD on the vehicle. the battery case behind the hook and loop fastener patch attachment. Warning: the VTESS transit case weighs 70 pounds. When handling the VTESS transit case, 2 persons must lift and carry the case by the handles provided on opposite sides of the case to ensure proper weight distribution. In order to prevent injury, lift with the legs, not the back, and avoid twisting while carrying the transit case. Do not stack the case more than 3 feet above ground level. Should injury occur, perform appropriate first aid and seek medical attention. The VTESS is stored and transported in a customized wheel transit case. A semi-rigid foam insert inside the case supports the VTESS components.